All right, so for today's notes, we're going to be talking about negative and zero power rules. The first thing we want to do is just go over some patterns, okay? So if we're going to start with looking at 2 to the 2 to the first power, okay? So we're going to start there and expand it and work our way up, okay? So anytime we say 2 to the first power or just 2, we can just write 1, 2, right? Because it's 2 by itself. When we say 2 squared, this is like saying 2 times 2. And when we say 2 to the third power, that's like saying 2 times itself 3 times, right? And then same thing with 2 to the fourth power, right? That's just our definition. That's our lesson 1, right? So when we go to our results, obviously the result is 2 to the first power would just be 2. 2 squared would be 4. 2 to the third power would be 8. And 2 to the fourth power is going to be 16. So as we are working our way up this progression, all we're doing is we're multiplying by 2. Okay. So if I were to reverse that, we'd just be dividing by 2, right? Okay. All you have to do at this point is continue the pattern. So if I'm looking for 2 to the 0 power, right? What is 2 to the 0 power? That's going to end up being 2 divided by 2, which is just 1. If I want to keep this pattern going, if I want to figure out what 2 to the negative 1 power is, I'm just going to divide by 2 again, right? So this would be 1 half. If I want to find 2 to the negative 2 power, again, divide by 2. 1 half of, 1 half divided by 2 is just going to be 1/4. And if we keep this pattern going, we have 1/8, 1/16, right? So one of these ways we can think about this is, okay, notice how as we're going up, I'm going 2, 4, 8, 16. And as I go down, it's now going to be 1/2, 1/4, 1/8, 1/16. Essentially, all we're doing, and when we have a negative power, is we are taking the same power and just flipping it. And that's actually going to be the rule for today, okay? So when you go down here, if we're talking about, we already had the product rule, we have our quotient rule. Anything to the 0 power, anything to the 0 power will always be 1, right? So when we talked about this rule right here, to the 0 power, that goes for anything. I could say 5 to the 0 power is going to be 1. A billion to the 0 power is still going to be 1. Okay. If we're talking about negative powers, all we're going to do is flip our number. Okay, so say we have x to the negative m. You can write this as 1 over x to the m. I'm just going to flip it and change the sign from negative to positive. If I have a number on bottom, so say I have 1 over y to the negative n, I can write this as y over n, and there's 1 underneath here. We don't have to write that, okay? So those are your 2 rules. Please write those down now. All right, so let's look at our examples for this, okay? So we're just going to be working through all our examples. So example 1, simplify with only positive exponents, okay? So I have x to the negative 2 power, right? Again, when we have a negative power, all we have to do is flip it, right? So if I'm going over here, I want to put this down here and make it positive. And what's left on top is just 1, right? There's nothing else for us to simplify. Keep it really simple, okay? Eliminate your negative powers, okay? So over here now, we have y to the negative 3rd and x to the negative 4th, right? So I have, again, we have a negative power on bottom, we have a negative power on top. We're just going to move them, right? So this y to the negative 3 is just going to go down. We're going to end up with y to the positive 3, and y to the negative 4 is just going to move up and become positive. And we can't simplify anymore. Okay. So now let's take a look at this. All right, so we are multiplying 5 to the negative 2 times 5 to the 5th power, right? So we can use a couple different rules here, right? So we have the same base. There's a couple different ways we can think about this. We can either go straight to moving my negative power down, or I can notice that I have the same base and combine them, right? And that's what I'm going to do, right? I have the same base, so I'm going to add my powers. So So we're going to say negative 2 plus 5. Well, negative 2 plus 5 is just going to end up being 5 to the third power. 5 to the third power is just 5 times 5 times 5, right? That's 125. And you can use a calculator for this. If you cannot do that in your head, please use a calculator. There's a class set just for this, problems like this, okay? So same thing here. We do letter B. We have same base. We can add the powers. So we're going to get 4 to the 2 minus 2, right? When you add a negative, you're just subtracting. So 2 minus 2 is 0. So this is going to end up being 4 to the 0 power or just 1. Okay, anything to the 0 power is 1. Okay. All right, so when you have 0 powers, you really got to pay attention to where that power is, though. Okay, so if we look at example 3a, I have 3 times x to the 0 power times 4, right? So I can, let's go ahead and take care of the powers that are easy to take care of, right? So if I look at the inside, we have 3, well, x to the 0 power is just 1 to the 4th power. Well, 1 times 1 times 1, 1 times itself 4 times is just 1, so this is going to end up being 3 times 1, or just 3. Okay. But again, it doesn't matter what you're raising to the 0 power. Anything to the 0 power is just going to be 1. So as we're looking at letter B here, we have 3,427, x to the 5th, y to the 7th, z to the 20th. That's a really ugly problem. The problem is everything is raised to the 0 power, okay? So the answer just ends up being 1. All right? And that is the notes for lesson 2 on negative and 0 power rules.